Good morning, good afternoon, good evening. Not sure where in the world you'll be watching this, but it's a pleasure to talk to you today. My name is Michael King. I work for Ocean Infinity. And I wanted to talk to you today a little bit about our new fleet of robotic ships and how we are going to be using them to provide better, cleaner, and faster data to the offshore wind industry in APAC. So I'm just going to share my screen a moment. Hopefully you can all see that. So before I begin, I just wanted to talk a little bit about Ocean Infinity's mission. So you can see our mission statement on the screen there. We use innovative technology to transform operations at sea to enable people and the planet to thrive. It's a simple enough statement, but bearing this in mind in everything that we do at Ocean Infinity really helps us push towards our goal of carbon neutral offshore operations later this decade. The new ships that I'm going to talk to you about today, the way in which we handle our data that I'll touch on later, and our overall ethos really helps us provide fantastic solutions for the offshore renewables industry, but always bearing in mind that we have a responsibility to keep our oceans as healthy and as safe as possible. A little bit of background on us before I talk about the more technical elements. We're a relatively young company. We were founded in 2016. And since then, we've been known for our multi-fleet AUV operations in deep water. We've taken part in some fairly well-known projects around the world. But back in 2020, just before the COVID-19 pandemic, we announced the building of the Armada fleet of robotic ships. And we're currently in the process of building 4 sizes of robotic ship that I'll touch on a bit later in order to take our automated and remote operations to the next level. Since then, in 2021 and 2022, we have acquired a range of businesses into the Ocean Infinity Group from around the world in order to really bolster our offering in the offshore renewable space, from survey, inspection, geotechnical, geophysical work, right through to data analytics and machine learning, which I'll touch on a little bit later. As you'll hear from me today, the first of our robotic ships are now launched and they'll be operational within the next couple of months. And our global network of remote control centers that we're building will enable us to support remote operations around the world. Our technology fits very much into 3 categories. Firstly, and probably the largest, is our maritime robotics. We have green ships, green technology, in order to primarily reduce the number of personnel that are required to go offshore. We're working with a few different businesses to pioneer green fuels and marine fuels of the future in order to achieve our carbon neutrality. And as I said before, this really pushes us towards sustainable operations. The second pillar of our technology is our data analytics. We use automation and machine learning to yield better results. We have faster, more efficient data delivery, utilizing some of our remote control technology in order to give data to our clients even earlier in the process. And everything is hosted on a cloud data portal, which gives people access to data when they need it and the answers that it gives. The third part of our business is very much our software division. We have an in-house software company that writes a lot of our own internal software, but also works with third parties and other suppliers to further optimize off-the-shelf software that we use for our survey work. We can provide 3D subsea reconstructions, we can provide digital twins, we can provide a full digital ecosystem to some of the data sets that we acquire, really helping you to get more out of your data set rather than have to acquire even more data. And I'll talk a little bit more about that later on. The final thing I wanted to say before I move into the technical portion of the presentation is really about our plan for the next 10, 15, 20 years. You can see on screen there that we're already working very hard with partnerships to restore and protect ocean health, look at getting more people into STEM roles earlier in their careers and engaging in educational partnerships. We're already single-use plastic free in our facilities and we have carbon neutral offices. But later this decade and moving towards 2040, we really want to push forward in our ESG goals. We want to achieve B Corp certification. We want to start sending zero waste to landfill and really try and close some of the gaps between different people in our workforce. Eventually, by 2027, we want to be carbon neutral at sea. A lot of that comes down to reducing offshore headcount and pioneering those future marine fuels that I talked about. And eventually we want to be a net zero carbon business across scopes 1, 2, and 3. But the main part of what I wanted to talk to you about today was really centered around our new robotic fleet of ships that we're building and we're going to be operating from 2023 onwards, and how that enables you in the offshore renewables industry to really take advantage of some of the technology that we're delivering. So we're currently building the world's largest fleet of low emission robotic ships. We call them Armada. These will be uncrewed and lean crewed vessels ranging from 21 to 86 meters in length. And they'll be capable of a wide range of offshore operations, from hydrography, geophysics, seabed mapping, survey, IMR, right through to geotechnical drilling and seabed sampling. The first of these vessels have now launched. We've got 10 others currently in build and a total of 23 vessels on order. They'll initially be launching in Europe in 2023, but by 2024, we will have some of these vessels in Asia Pacific for the local renewable market where you are. As you can see here, they look largely like normal ships. They have a pointy end, they have a flat end, they have a wheelhouse and a back deck, but really these ships have been designed from the ground up. You know, they are completely custom built in order to fit our specifications exactly. So they have different technology on board, they have different control systems, they have different communication systems and IT infrastructure. And really this will enable us to go from what we see today, which is a picture with maybe 30, 40, 50 people on a vessel of this size, through to our lean crewed model that will be operating later this year. So these 78-meter ships that you see on the screen now have a maximum complement of 14 people, and that's already a dramatic reduction compared to a conventional vessel of that size. And of those 14 people, most are actually involved in the operation of the vessel themselves. The regulations won't allow us to operate this vessel without any people on board yet. So we have a small marine crew offshore in order to help us do those tasks. However, all of the payload control, the data sensors, the vehicles, everything like that we will be deploying from these ships will be controlled from one of our global remote control centers that I'll touch on in a moment. So you're already seeing that even though these are not uncrewed, they're lean crewed, we will still have people offshore for a while. There is a dramatic step change in those offshore exposure hours, which yields better HSE exposure, or less HSE exposure, I should say, but it also yields more efficiency throughout the whole project. So I touched on those remote control centers, and we're building a global network of these. So we have one in the UK already. It's based in Southampton on the south coast to support our European operations. And we're also going to be building one in Asia Pacific over the next year. And these control centers are completely, again, custom built from the ground up. They are, you know, designed with absolutely futuristic and future-proofed operations in mind. So all of the operator stations, all of the control stations are completely multi-role and modular. We didn't want to get to a situation where we have one chair for a vessel pilot and another chair for a surveyor and another chair for an ROV pilot. We wanted all of the stations to be completely multi-role. They're run on a completely virtual network, and this allows access to multiple systems from a single station. So the people who are working on these environments and working with our ships can access all the different data flows that they want in real time. You know, it means that people who are responsible for data processing and data quality can access all the different information without having to switch computers. It means that the vessel pilots and the ROV pilots can access different views and different sensors without having to worry about the compatibility of all of that. And ultimately, human factors have been at the absolute forefront of the design process throughout. Even the temperature, the colors, the textures, everything in that room has been designed to facilitate the best working environment for our personnel. Ultimately, we believe that our personnel are going to be spending a long time in these rooms, you know, providing detailed support to complex operations, and we want them to be as comfortable and as healthy as possible. However, it does bring its own challenges. You know, when you're trying to combine detailed, complex vehicle and data operations with a remote control center technology stack, you have to really build in the opportunity to link those technology stacks through satellite communications. So firstly, we have what we call dynamic payload control. And these payload controllers allow us to operate geophysical sensors, ROV, LARS systems integrated with vessel operations at every stage. We have automated launch and recovery sequences for different towfish, for different vehicles, both subsea and aerial. And we have all of the safety interlocks that you would expect to mean that we have, complete human in the loop operations at every stage. The video and telemetry transmission over low bandwidth links is a challenge, but the way in which we're building our control system will allow us to provide real-time data insights from our remote control centers. So the days of sending client reps offshore and having to wait for feedback and having to wait for data to be transmitted back to an office or a facility is over. We can give real-time access to a lot of the data that we're acquiring from the comfort of one of our remote control centers. And that will really enable you to get data earlier in the process to inform other projects. And then the second part of it is actually about the sensor command, control, and data acquisition. So we have the dynamic payload control that handles the physical devices, the physical sensors, and the physical vehicles. But then the sensor command and the data acquisition is yet another challenge that we have with this remote setup. So we need individual sensor command and control. We have to be able to look at the different acoustic and geophysical and hydrographic sensors that we're operating. But we need automated data handling and initial appraisal by machine learning and by artificial intelligence so that we can provide that real-time feedback for online quality control. You can't operate over a low bandwidth, high latency link and expect data in real time without giving a certain amount of thought to machine learning. So if you can take a complex data set and you can put it through a practiced machine learning model, and you can then start gaining insights straight away before a human has ever seen the data, then you get even faster access to that data over that low bandwidth link. So the way in which we're building our data acquisition and data analytics technology stack really supports that kind of operation. Moving on from the actual data acquisition itself, the requirement for absolutely vast amounts of data in offshore wind is becoming ever more prevalent. And, the amount of geophysical and hydrographic information that is acquired when you're doing surveys for offshore wind stretches into the 10s or 20s or 30s of terabytes. And hosting all of this information, appraising all of this information, and analyzing all of this information is really, really vital to the whole process of site characterization for offshore wind. And we're trying to innovate not only how we acquire the data through our new ships, but also how we handle and manage that data through its journey right through to the deliverables. So we are innovating payload control, data collection, data processing and interpretation, and really giving our clients and our stakeholders access to those answers and the data analytics and the models much earlier in the process. And really throughout all of this, it's important to remember that changes in system design are needed to support our robotic ships and our remote operations in order to help us provide quality data products. So if we look at the data journey of how this works at Ocean Infinity, so traditionally on the left-hand side of the screen there, you can see the conventional data journey. This is not new. This has been happening for a long time. You have a ship offshore with 30, 40, 50 people on board, perhaps, and you have those people looking at data in real time, and you have them appraising data and doing the earliest parts of the analytics on a project, sure. And then either when that vessel comes into port or at the end of a project, those data sets are sent back normally to the survey company's office, and those people then in the office will do post-processing. They might have to redo some of the offshore work because it might have got lost in the transfer. And then they provide the onshore interpretation, onshore reporting, and calculate the final deliverables to be delivered to the client. And that's how it's worked for decades. And it's a perfectly valid system. However, there are a lot of inefficiencies in the way that works. The Ocean Infinity data journey and the way in which we are building our data infrastructure to enable us to take advantage of the robotic technology relies around a lot more offshore automation. It relies around remote communication and access via various satellite links, GSM networks, etc., and really allows a combination of personnel, but also machine learning and artificial intelligence to do all of that data analytics in one step. You don't have offshore personnel and onshore personnel having different ideas or different interpretations. You have one group of people in the same place providing really detailed analytics, supported by remote comms, supported by machine learning, supported by artificial intelligence, to provide much faster, much more efficient assessment of data and, more expedited delivery of some of the data products that our clients need in order to carry out their projects. But the final thing I wanted to touch on, and this is quite detailed, is it possible to get more from your data set? Everything's becoming more expensive in the world. It's costing more money to send ships to sea. It's costing more money to acquire data. It's costing more money to employ people. So if you're spending however much you're spending on acquisition of site investigation data, is there a way in which to take a data set, which could be complex, many sensors, many locations, many vessels, is it possible to gain more information from that data set in order to provide more value from that data product? And we view this as a three-step process. So firstly, once you've acquired the data, you have to understand it, okay? And to understand the data, we use, as I've mentioned before, automated processing and object detection. We use machine learning methods applied to data sets, both in real time as the data has been acquired, but also afterwards, to get some really excellent data products that we genuinely have faith in, we have confidence in, and the processed data is a fantastic deliverable in its own right and can be used as such. It can be used for engineering, it can be used for detailed offshore wind design, it can be used for cable installation, whatever that might be. So that's kind of the basic understanding and production of a data product. But we think we can go a couple of steps further, and reconstructing the data set in 3D, in 2D, in a GIS project using SLAM technology, it really enables us to take what is a basic data deliverable and provide 3D volumetric reconstruction, for example, be that of the seabed or of a subsea asset. We can look at existing infrastructure or existing cables using SLAM technology and really start to provide more insight into the current state of whatever we have just surveyed, be that virgin seabed, be that an existing asset, be that a cable route. By reconstructing that data into a full 3D environment, it gives us the ability to provide more insight from that same data set. The third thing is really to put that data into context. Data's great. We all love data. We're all in a data business, and data is what the world is run on. However, contextualizing and correlating that data with timestamps and with accurate GIS positioning allows us to provide context in three settings. Firstly, there's a global context. Obviously, this is really important with the focus on sustainability, the UN's Sustainable Development Goals that we support wholeheartedly, and really taking the amount of information that we're gathering and donating part of it to science or to academia or to GEBCO or to Seabed 2030, for example, and really allowing other users of the ocean and other philanthropic organizations to benefit from the use and benefit from the acquisition of that data in a global context. The main one is obviously an operational context. We need to make sure that that data is fit for purpose to support whatever operation is going to happen, be that construction, cable lay, engineering design, feed studies, whatever it might be. The operational context is absolutely critical. But there's also a historical context that we see, particularly in Europe and the US, and we will start to see in Asia Pacific, is that historically the sea was in a different place. Sea level rise, sea level change has happened over the last 10,000 years. And the historical context of some of the data that we acquire in coastal areas really matters to some of the paleo landforms, paleo settlements, and paleo people, paleo humans that used to exist in these coastal environments that are now underwater. And the ability to put some of our data into historical context and have an appreciation for what has changed over time gives us a really important insight into the landscape and into the way in which the coastline and the seabed is likely to behave in the future, which is obviously critical for offshore construction projects. So we at Ocean Infinity believe that a data set is good. A data set is fantastic when it's acquired and analyzed and delivered properly. However, you can take it a step further and you can provide more reconstruction and more context to that data if you know the tools that you have available to you in order to provide that additional insight. Obviously, we're a technology-driven business. We are building and developing and bringing a lot of our technology to market. But really, that's just the start of what we're doing. We have more ships in build. We have, more machine learning and more more artificial intelligence to come, which will support our operations and our data analytics. But we also want to challenge the rest of the industry to work with us on this. We challenge our suppliers to deliver more advanced equipment and more advanced sensors so that we can take even more information from a data set. We want to build even more intelligent ships of lots of different sizes for lots of different things. We want to provide smart shipping and cargo movement and everything that ties us together as a genuine provider of marine robotics. Everything ties together in a single technology stack to enable really efficient and really clever data analytics across a range of different industries. Of course, at the moment, the majority of what we do is for offshore renewables around the world. However, we believe that as the renewables in Asia Pacific, for example, get built out, and as the wind farms start to appear, our technology and our technology roadmap will enable us to provide services across the life cycle of an offshore wind farm, from cargo movement to O&M services right through to decommissioning. And it will enable us to provide even more sustainable solutions as we move forward into the future of offshore wind. So to finish, I just wanted to bring it back to this slide again, because I said it at the start that this is really important to us, that we use our innovative technology to genuinely help people and the planet to thrive. And it really does matter. We want to provide, yes, we want to provide effective services that, provide our clients with great data and provide other stakeholders with important information. But we really do want to do it as efficiently and as sustainably as possible. And I hope that what I've talked to you about today shows that we're committed to that across the board, not just in the ships themselves. So thank you very much for your attention. I'm sorry I couldn't be there in person, but my contact information is on the screen there. So if you have any burgeoning questions, please reach out. And I look forward to speaking to you again soon.